All right, so this is the video for seniors in my calculus class. What I want to do here right now is this is going to be part of your like short answer, extended response, whatever you want to call it, for calculus. What I like to do every year is try to take a time, like relate something just to connect what we've been doing before we do like video games like Angry Birds. But I think at this point it would be really appropriate to use all the COVID-19 numbers just to kind of help relate to how calculus can be used all the time. So I'll just show you guys what I've made here, and then we're going to talk about it, and then you guys will answer some questions. So kind of try to pay attention a little bit. Probably give some answers away to help you guys out. So what I've been doing the last few days, actually didn't want to, I just wanted to minimize it, move it down here, is I've been keeping track of the numbers. And I have roughly, today is May 11th, and it is 2:17 in the PM. So the numbers for today were just released. So this is as accurate as we can get. Like 72 days worth of data. So this is Ohio's total numbers. So we're not going to talk about like recovered cases or anything like that. These are just confirmed cases in Ohio, including deaths. And we can talk about how those numbers get affected too. Here. So I got 72 of them. I did add a couple, like a week's worth of zeros or 8 days worth of zeros. Ignore this E1 number. That's just a statistical number, just to give us a little bit of a flattened date, and then started seeing the cases. So I pulled these first numbers up online, and then they stopped putting them up there, and I had to go back to another resource to find them. But you guys can see the cases, and you guys remember how it just happened. And you guys can see the trend of the graph here. So as we can see, we started off real low, and then it started to increase, and school was out and we were getting worried, and then it really took off this week here, and then afterwards we were still going up, but I mean, we're getting to the point right now where people say, we want to open things back up, but we can see like this would have been great if, let me try to get my annotation here. This graph would have went, flat like this, obviously goes up, and then started to show a flattening here. And every day, like we'll get small little 1-2 day trends where we're like, all right, it's starting to slow down, and then pops back up. But there's reasoning behind that too. But we don't have that. So we're going to talk about how this is related to calculus. Well, those are numbers that are great. They tell us the total numbers, but it's hard to do any kind of predicting from that. We'll actually talk a little about predicting and data numbers that we can use. But for right now, we can't. But you know what? I should double check that I am sharing this. Okay. Okay, so what I've also done here is I've made another graph, this one, which is hard to tell, but I will zoom in. I'll click this button to zoom in to focus this one. Here, there we go. This graph you can see is a lot smaller, but this is how many new cases were predicted each day. So all I did was just kind of subtract them here, but you can start, there weren't many new ones, and then we can start to see we got, this is over 500. We started getting around, like 400 per day, and then it jumped up and we were getting close to 1,500 per day. And now we're in this new kind of curve where it's definitely not 1,500, but we're getting well over 500 pretty much each day, 500 to 600 each day. And that's been going on for several days now. Now, this is the graph that I think is really important. This is the graph we can do stuff. This tells us how many new cases per day. So the one thing about this is that we should know is that realistically, this graph is going to start off low. We have a little bit new people. Then it's going to peak up, get to its highest curve, its highest point where we get the most people infected, and then it should drop. Now, there's going to be other factors too. We're going to have more people being tested. We're also going to have, cases where they spike up and down, like in Mansfield when all the prisoners just got sick. Well, yeah, because they're all close together. Those are things that are going to happen. Those are going to skew the data a little bit. But roughly, we have a bell curve where it goes up, flatten, and then goes back down. So what I've made here to align with this is I've made a bell curve graph. And I think this is the one I can use here, where there's kind of 3 key features to the bell curve. And if you know that, there's the center of this. So I made a variable here, and this is all just a prediction that I'm using. We got a center here of this equation, and it looks definitely like the peak is centered there. We have the B value, which kind of determines the width of the bell curve. And so we'll mess around with that a little bit. And then the C number, which I think is the magnitude. And it seems to be, now I'll put it a little bit higher than that, just because we know realistically here, we seem to have a peak, around this day, around day 50, if you want to call it, of this. And there's some reasons why we should be above and below the graph. This B value, I'm just gonna kind of stretch it up. Like realistically, we probably know here is that during this time here, even though these numbers are well below our estimated curve, we know that the testing wasn't readily available. I think we've improved our testing in the last 3 weeks by 600%. So we were testing around like 6,000 or 4,000 cases a day, and now we're doing over 20,000 cases a day. So these numbers should have been higher if we could have tested more people out. What might be happening too, which is kind of the scary part, at least to me, is that these numbers were low and then they got higher because it took long to test these. I mean, if you hear about some of these stories, some of these testings, yeah, we have the 15-minute testing, but we're not always using those. So these would have been people who would have been sick, but then they all get tested at the same day here in a mass testing, and then those numbers go up really high. So who knows, like, if these numbers are true or not. But really, there's only one way to find out. So we're going to say, like, this represents the curve here. Okay. So let's talk about calculus here. How can we use calculus to help us out? Well, there's two big things that we have in calculus. There's the derivative, there's the integral. So we have this function f of x, which here is, if you actually look at this equation here, this represents how accurate this is to the data we have. So if we want to have like an r squared value that's as close to 0 as possible, I'll flatten the bell curve out a little bit, or actually it wants me to reduce that, but I'm just going to eyeball this. I'd say that looks like a pretty good representation. So these numbers are going to be what they are, but let's talk about how the graphs can help us out. So let's talk about the derivative. So if this is the amount of new people per day, if I make a new graph that say like y equals f prime of x, which is awesome in Desmos because it will graph it for us. It takes this f of x equation and graphs the derivative of it. We have some key features here. If we look at first, we get a derivative. Remember, this equation here is, let me change the color so it doesn't match any of the other ones. We'll make it orange. This derivative equals 0 at day 50. So remember, derivatives indicate highs and lows, mins and maxes. So when we have a derivative equals 0, we have a change in direction. So that is the maximum point. So where did we get the most amount of new people? Right here. The other thing that I find interesting is these peaks of the derivative. So around day 40 and around day 60, these are when the rate of change is changing the fastest. So this is the highest point of the acceleration. So if you think about here, what that means on a graph is this is the quickest that it's changing per day squared. So we would have points here. Now, it isn't changing the most. We aren't getting the most people here. This is when we're going to get more and more people per day. And if you look over here on the other side, this is when we have the lowest, when it starts dropping the fastest. So all here, remember, anything below this graph means we're still getting new people per day, but we're getting less. That number is getting smaller. We're still getting more people per day, but we're getting a lower amount of people per day. And so something like day 60 here is when we reach the lowest amount of new people per day. And I always kind of think about, that's probably, I mean, today's day 72, so roughly 2 weeks ago, when people hit that point and start to realize like, hey, we should be reopening stuff. Look at these numbers are dropping lower, not knowing that, okay, yeah, this is going to be recursive. That number isn't going to get smaller, and keep on getting smaller until it goes to 0. It's going to slowly get smaller. And that's just the way the bell curve works. Okay, if we look at this, we have this amount of new people per day, which I think is the more important number to look at in all of this, not the total number. We can say the total numbers used to scare people, but with the amount of new people per day is a good graph to look at, because the derivative can tell us, when are we going to reach the peak, and when are we having these extreme cases of gaining the most new people per week. So like a day like this is we have to look back and be like, okay, what happened these days? How did we get the most amount of new people per day? Because that's going to affect when we reach the peak a few days later. And same thing right here. What happens? Okay, how do we respond to when our numbers get lower? Well, we can't just say everything's okay and go good and let people know. And then one thing, I don't know, I'm getting kind of personal here, but it's a good topic. When you get on Facebook and you see some things people post, like, think about it. You guys are pretty smart people. You guys are some of the smartest kids in the school, just math-wise and statistically wise. And just how difficult something like this is able to predict. Like, how hard is it for you guys to make an equation? Like here, I'm using tools on Desmos to follow along just to be able to estimate roughly these dates here, roughly these numbers. And this is just a straight up bell curve. Our numbers are not going to be a bell curve. If we actually know anything about this, and this is what they were predicting last week, I'm going to annotate, the bell curve isn't going to be nice and smooth. The bell curve is going to go up like this. It's going to drop, but because of trends of people's predictions and people's behavior and testing, we're going to have other humps. So a simple bell curve function like this, and this right here, this function here is a simple function as math speaks goes, like as statistical predictions go. This is simple. Something that involves more curves and more bumps, it's going to be more complicated to predict. Something that the modeling is always hard to understand. So it's one thing to just recognize the difficulty of the job that's ahead of us. Yes, we have some really, really smart people that work in our country, and really, really smart people all over the world, and really, really smart people in our town. But it's just a science. Like, it's just an idea, a hypothesis. And that's what we're just trying to do, is to help you understand this. Sorry, going on a rant there. So as it comes to testing, what does the derivative do? It tells us like these new people per day. So the acceleration that things are happening. And we can find out clearly, when did we reach the highest point? That derivative equals 0. It's always going to be a key number to look back at. All right, so there's derivatives. Let's get rid of that. I need my mouse here. The other thing that we use in calculus is integrals. And this is where integrals will not so much help us, well, they can help us predict, but let's remember, integrals find the area underneath the curve. And so if this graph here, this bell curve, represents the total amount of new people per day, if I go backwards from that, that's just going to be the total amount of people. So if I wanted to make up an integral equation and say, okay, what's the integral? I got to use the toolbar here. Functions, miscellaneous, integral from day 0 to day 40 of f of x dx. This is going to be interesting here. We'll say it says 5,363.4. So unless we have some unborn children or something like that, no. 5,364. Let me actually go back to this chart here, see what was our total for day 40. See how accurate that was. Well, we had 5,500 that day. So that's a fairly good approximation for day 40. And that's one thing to look at. Let's do another one just to kind of check. You know what? Let's do the worst that could be. So I would guess we had a peak at day 50. If we were fairly accurate through day 50, which is 17,590, go back to the chart here. Day 50, it was actually at, well, no, that's backwards. Wrong one. This is the one I wanted to look at. Come on, show all. This was kind of hard to just keep track of everything. Day 15, okay, we're at 11,602. So we were predicting well more than that. Now I'm getting all messed up here. So what was the integral prediction? 17. So yeah, that was like, what, 600 more than that? 600 cases really isn't, it was just one day nowadays, or 6,000. Oh, it was 6,000. So that's a pretty big difference. But you can see here, our curve goes well above what it was looking at. So something like this as well. Let's look at day 70, just the other day. what is the prediction for day 70? 34,000. Okay, yeah, we're getting pretty off here. So maybe we should adjust the curve. Maybe I should change this B value. That's just going to change the magnitude of it. Oh, look at it. That actually affects it. You know what I'm going to do? Well, we're on day 72. I know today it was just released at 24,500. So let me, don't want to change your C. Change your B to 24,500. Maybe we'll go up to 125,000. Probably right. Okay, so we got this graph here. And the one thing that's nice about this graph is we can then use to predict. Okay, so it is May 11th. So that's day 72. If I want to predict the end of May, so we want to add on, what, 20 more days here, roughly. So, okay, what's day 90 then? Okay, and then we're at 25,000. Okay, that wouldn't be too bad. In fact, that's really low. But if we look at here, we're predicting that these numbers start getting really slow by then, but we're not doing that. It's spreading out more. Okay, what's it going to be like at the end of June? Okay, 120. Oh, that's just barely even more. So the one thing that we can do is we can use the integral kind of for two things. We use the integral big thing to find the total amount of area underneath the curve, but then we can predict the total number. So this is where people will start to worry about, okay, how many hospital beds are we going to need? You know, if people are going to be in the hospital for 3 weeks, you know, what's the total number? And these are just modeling guesses. Now we can see this bell curve, our numbers are way lower because these numbers at the end are still getting longer. It's not going away as quickly as it should. So our numbers should be maybe out to here, where our beginning numbers are very wrong, but our end numbers are more accurate to what the totals are going to be. Okay. Sorry going on a little rant there, guys, but I think it's really important to kind of look at what we've done in calculus this year of the two big concepts, derivatives and integrals, and how they're used. So here we're using statistical data. There's a lot of jobs out there. Actuarial scientists are huge right now. What those guys do are basically they do giant math problems and they do statistics like this for insurance companies to help. So they work with numbers and charts and they just look at, okay, what's the probability of this happening? How bad would it be versus the probability of this happening versus how well bad it'd be. So this is where we had, like at the beginning, those graphs where they had the models go up. I got to do this. And, you know, some would go this way, some would go that way. And because of our efforts with, you know, social distancing and other things like that. But hopefully this can help answer your questions. Sorry to make this pretty long, but I just want to say, like, I really appreciate you guys having me this year. You guys were really great. Always appreciate the first class of the day for me. You guys were good. So enjoy your time. Really sucks that your guys' year ended off this way, but that's what it is. So have a great one. I don't know, finish the year strong. Have a good summer. Do the best you can, but stay safe, guys. All right. Good one.